That's right, I want to implement 10 projects with one rule. I'm not allowed to use any if statements and no conditional operators at all. Not even this question mark, and even switch is not allowed. Is something like this even possible? The idea came to me when I thought about how CPUs work. Inside the CPU, we only have registers, zeros, and ones. The CPU obviously doesn't decide things like if it's 0, do this, if it's 1, do that. Under the hood, it's all just bit operations happening. So if the CPU can do it, we should be able to do it too. After doing a bit of research, I figured out what we could do. The best option is to use C, because we're going to use a lot of bitwise operators, and these operations don't really exist in higher level languages like Python. The only operations we actually need to figure out are equality, greater than, and less than. The rest can all be built by combining these three. To implement equality, we use the XOR operator. What XOR does is compare every bit of two variables. If the bits are different, the result is 1, and if they're the same, the result is 0. Then we apply NOT to invert it. Now it's time for the greater than operator. The bitwise version looks like this. I know it looks scary, so I'm not going to explain it here. You can try it on paper yourself if you want, but if not, just trust me. This formula is equivalent to the greater than operator. Less than operator is implemented exactly the same way, except the order of subtraction is reversed. Greater or equal is just a combination of greater than and equality. Less or equal is a combination of less than and equality, pretty much what their names are. Not equal is simply the opposite of equal. Now I know some nerd is going to look at this and say, wait a minute, you used not twice. This should give you the original value. Nope, when you XOR two numbers, you get an integer as the result, not just 0 or 1, which is what we want. When that value gets negated once, it becomes exactly 0, and when it gets negated again, it becomes 1. So this is probably the only place in the world where double negation doesn't give you the original value, which is pretty cool. Alright, we're past the boring explanation part. Let's move on to the projects. The projects are ordered from easiest to hardest. The final project is Minesweeper written in C, about 2600 lines of code. In this video, I'm going to build the entire game without using a single conditional statement, which is probably the hardest thing I've ever done. But let's start with the simplest project. The first project calculates the factorial of a number. The code has an if statement to check if the number is positive, and a loop to perform the multiplication. At first, I wanted to remove the if, but honestly, I couldn't bring myself to do it, so I combined it with a for loop instead. Is it efficient? Not really. But if you're looking for clean and optimized code, well, you're in the wrong place. Anyway, now there are no conditions in the code, right? Though technically, the for loop condition still contains two comparison operators. So I replaced them with the bitwise formulas we built earlier. And the result is this. And just like that, project number 1 is done. In the second project, the program takes a string and converts all lowercase letters to uppercase. All we need to do is check if the ASCII value of a character is between lowercase a and z. If it is, we subtract 32 to convert it to its uppercase version. Inside the loop, we can actually remove the null check entirely, because the null character is already 0, so we don't really need to check whether 0 equals 0. But we can also use a neat trick here. The condition returns either 0 or 1, so we can subtract 32 multiplied by that condition. If the condition is 0, we subtract 0, the character doesn't change. If the condition is 1, we subtract 32, the character becomes uppercase. And just like that, project 2 is also implemented without any if statements. Project 3 is a bit harder. We need to draw a hollow inverted pyramid. This is probably the hardest example among these shape drawing problems. And here I ran into a problem that I had been trying to avoid this whole time. Jumps. What an if statement does is jump from one part of the code to another. The bitwise operators we implemented only mimic conditional operators. They return 0 or 1, but they never perform a jump. In the previous projects, I managed to remove every if, but here that's not possible. So I had to figure out another way to simulate jumps. And that's when I came up with this idea. You see this thing here? It's called a function pointer. It's a variable that points to a function. When you call the variable, it's basically the same as calling the function itself. So I created an array of 2 function pointers and stored 2 functions inside it. Then, instead of putting a number inside the array index, I wrote the condition in it. Now if the condition is 0, the first function runs. If it's 1, the second function runs. So instead of a conditional jump, we perform a function call. Tell me that's not genius. This technique is called table lookup or jump table. Let's rewrite the code and see what happens. By the way, I also realized that copy-pasting those formulas everywhere makes the lines extremely long, so I wrapped them inside a function to keep things cleaner. First, I removed the conditional operators, just to be safe. Then I defined an array of function pointers and stored 2 functions inside it. These functions return void and accept a variable according to the code. Now I call them and place the condition inside the array brackets. Let's see if it works. And look at that, perfectly executed. Project 4 is binary search, which normally includes if, else, and else if. But we don't actually need to make things complicated. The code can easily be rewritten so there would be no else-ifs. After that, just like before, we remove the operators and replace the conditions with function pointers. We repeat this process twice, and just like that, binary search is implemented with 0 conditional statements. Project 5 is matrix multiplication. Honestly, when I picked the projects, I thought this one would be pretty difficult for this stage. But looking at the code now, it's basically just 3 for loops. You know what? After all the suffering from previous projects, I feel like I deserve a break. So I changed the for loop conditions and called it a day. Project 5 completed. Project 6 is moving average. If you don't know what matrix multiplication or moving average is, don't worry about it. I thought this one would be difficult too, but it ended up being just 2 for loops and 1 condition that could be removed entirely. So this one was also very straightforward. But in Project 7, things are no longer simple. This code solves a quadratic equation. Here, I realized that instead of functions, I could implement the formulas using macros. When a function does something very small and simple, it's often better to write it as a macro, so it gets expanded directly during compilation instead of calling a function repeatedly. First, I rewrote the code so it would be easier to modify. Then I removed the operators. Then I replaced the if conditions with function pointers. The most painful part here was passing variables between all those functions. That alone took a lot of time. Project 8 is base conversion, and not a simple one. This code takes a number from any base and converts it to any other base you want. Did you know you can write this code like this? These 2 functions actually do the exact same thing. That's one of the cool things about programming, especially in lower level languages. You can solve the same problem in many different ways. This project was one of those stubborn pieces of code. It took me 2 full hours, but in the end, we had a working base conversion program without using a single conditional statement. Project 9 was actually a graphical window. I wanted to build this as a preparation for Minesweeper, which was waiting for me. In graphical programs, we usually need a switch statement to handle messages, so I needed to figure out how to replace switch without throwing a ton of function pointers. Eventually, I found a solution. Not the one that I'm proud of, but still. First, we determine the maximum value used inside the switch. Then we can create an array of that size. In the array indices that correspond to the case values, we place the corresponding function pointers. The rest of the array points to a function that does nothing. So if the message value is 1, the program goes to index 1. If it's 212, it goes to index 212. It's not beautiful, but it works. And now it's time for the pure torture to start. Yesterday I implemented 9 projects. Even if you doubled all of them together, they still wouldn't be half as difficult as this one. The first thing I did was merge all the header files into one, so at least I wouldn't get confused between files. In the end, the project reached 2,660 lines of code. I also created a header file for helper functions that simulate if-else behavior, and now there's no escape. It's just me and this code. Oh my god, what is happening? How can something be both fun and painful at the same time? Here... What is this? I think I'm the first person to get jump scared by an if statement. This is nothing. This is just a condition. God, it's 6 AM. What am I doing? I challenge you to try this in your own projects. Trust me, it's fun. 1 hour and 15 minutes. Maybe I should take a break. 1 more hour of coding. Bro, I need to sleep. While sleeping, I actually got some ideas that would make the switch replacement easier. Hold on to the explanation. It's funny, in the first project, I didn't want to remove an if statement, and now I'm just removing every critical if statement. Like, what do you mean if we need to check if the file is open? The file is gonna open. What's gonna fail? Yesterday, I figured out another way for replacing switch. In some places, the values went up to 512, and I obviously didn't want to create a 512 element array of function pointers. So I wrote a helper function that maps the values used in the switch into smaller numbers. For example, if the switch needs to check whether the value is 1, 2, 201, or 512, the helper function converts them into 1, 2, 3, and 4. After that, we can use a much smaller array. The code becomes cleaner. Unfortunately, the last two recordings were cut off by half, and the moment I finished the project was lost. But overall, I spent 2 hours and 40 minutes coding today. And finally, it's done. Ladies and gentlemen, Minesweeper, a complete project written in C without using a single if statement. Let's search through the code. No if, no question marks, no switch, no conditional operators either. If you check the assembly code of this program, there are no conditional jumps either. These are the conditional jumps in assembly. Pause the video if you want to read them. But aside from the jumps used by loops, you won't see conditional jumps anywhere else. Let's search. JNS is 0. JS, JL, JLE, JGE, JG, JNO, JN, JC, JNC, JZ, JNZ, they're all 0. None of them exist in the code. But JE, JNE, and JNP do exist because they are related to loops, which were not part of the challenge. This last project alone took about 11 hours, and all of the projects together took about 15 hours. So for the suffering I went through, please like and subscribe. Let me know what you think in the comments, and see you in the next video.